Okay, here we go. Hope it's taken. The study of functions. So again, different schools of thought of how to teach math, right? Because I am super, super old, I told my daughter the other day, I said something like, oh yeah, because now that I'm 60. And she said, stop saying that. And I go, Caroline, I turned 60 this year. She goes, oh, I know, but it makes us all uncomfortable. It kind of creeps us out. I'm like, that's hurtful. So because I'm old, I've been doing this a long time. So you got the textbook, right? You got the textbook. And I think of the textbook kind of like the Bible, right? Or the Quran or the Torah or any religious book. And I don't know about you, if you're religious or anything, if you've actually read those books, if you read them, they're super confusing, right? Like my husband grew up in Catholic schools, and we were at a hotel once, and I pulled out, so we had the Bible in there, and he goes, I think I've read that whole thing. And I literally opened up to a random spot. I read the passage, and I said, tell me what that meant. And he's like, it means Bible stuff. I'm like, you don't even know what this means, because it's super confusing, right? And that's why you have like preachers and pastors and imams and rabbis, because they kind of explain it. But some teachers will use the textbook because the textbook is the official way, and they'll explain it that way. And you're going to be like, I don't even know what that means. And the teacher will be like, yes, but that's the definition, right? So a lot of times I will tell you the real way, and then I'll tell you the Mrs. Tarantino way, which is not to say my way is wrong. It's just the simplified version. It's the way to feel like, okay, here's it very confusing, and here's what they're really saying, right? So functions is that, right? So you have been hearing the word function forever. And function means one thing. It means one thing overall. It means, I don't know why that's happening. It means it means predictable. That's totally all that function means. You're going to be studying stuff that's predictable. And here's why. Predictability is good, right? That's allowed, like civilization. If you go to the doctor because you've got a sore on your arm that might be like a little infected, and the doctor goes, I have medicine for that. And 80% of the time, it's going to get rid of that. 20% of the time, it will make you die. Like you're going to be like, do not give me that medicine, right? Because that's not predictable. That's bad, right? So we study stuff that's predictable, and we study functions that are predictable. When you put stuff into it, you have a pretty good idea that what's going to come out of it. And some of the functions we study this year, linear functions, I'm going to give you PTSD as I say these words, quadratic functions, polynomial functions, exponential functions, logarithmic functions. No, conics are sections, they're not functions. Rational functions, trigonometric functions, that's what we study. That's algebra, the study of functions. And the reason they're good is they are predictable. And let me tell you what I mean by predictable. So here we go. We've got a nice little vending machine. And I found one that mostly has Dr. Pepper. And I'm very excited about it. And it's got button number 1 right here. And I push that button every day. And I push it, and out comes icy cold, delicious can of Dr. Pepper. And I'm happy. And I pushed it today, and out came my Dr. Pepper. And tomorrow, I'm a little, I'm tired. I need a little pick-me-up. I go to my vending machine, and I push it. Out pops my Dr. Pepper. And I'm good. And the next day, I push it, and out comes my Dr. Pepper. And I'm good. And the next day, I push it, and out comes instead, someone made this for me because this is my example every year, a bag of human vomit. That would be bad. It would be terrifying. Who would do that? Who would put it in there? I would never go to that vending machine again because it's apparently got human vomit in it. Right? Look, it's got some weight in it. Right? Because things that are not predictable are not good. They're not functions. They're not usable to us, right? So we're going to talk today about how we can tell if something is a function mathematically. And I want you to think about it. The official definition is this. Each domain corresponds to a unique range. Don't write that down because that doesn't mean anything to you. Because you're like, I don't know really what that means. Because what I'm going to say to you, the Mrs. Tarantino way, is I'm going to ask you, is it predictable? So here we go. Are you ready? I'm going to write some examples down. You're going to decide with the table group, function, not a function. So here we go. I've got my little Dr. Pepper machine, and I push button number 1, and I get a Dr. Pepper. But my daughter does not like Dr. Pepper, and she pushes button number 2, and she gets a Coke. And my son does not like either of those. My husband actually, he pushes button number 3, and he gets the worst soda of all. That's right, root beer, because root beer is disgusting. You think it's Coke, but it's not. So here's my question: is that a function? Is that predictable? Yes or no? Talk to your table mates. Is that a function? Yeah, it is a function, absolutely. Because you know if you push 2, you get Coke. Today, tomorrow, the next day. Let me add one in. Button number 5, HV, you get human vomit. Is that still a function? Yeah, because what are you going to do if you don't want human vomit? Don't push 5, right? Don't push 5 because it's predictable, right? That's predictable. We like that machine. How about this one? I go in, let's change it up a little bit. I push button 1, I get Dr. Pepper. I push button 1 again, I get Coke. I push button 1 again, I get Sprite, which is just like low rent 7-Up. Is that a function? No, it's not a function because I'm pushing 1 and I don't know what I'm going to get, and I'm not. And unless you've got a button that says, dealer's choice, I'm not going to like that one. What if I brought this machine home and this is what the machine has? Button 1, you get DP. Button 2, you get DP. Button 3, you get DP. Function? Not a function. A boring function, yeah, but a function nonetheless. It's predictable. Predictably boring, you're going to get the same thing every time. But that's what it means. When we say the domain matches with a unique range, that means when you put in one thing, only one thing comes out. Does that make sense? That makes that bad boy a function. So when we do it with math, 2, 3, 3, 7, 5, 9, that's a function. That one's a function. But the minute I do this, it's not a function, because think about your machine. If I push 3 and I get 7 today, and I push 3 and I get 9 tomorrow, it's not predictable. Does that make sense? So while teachers have taught you this whole you domain and that's predictable. That's all it is. All we're talking about is predictability. Okay, so let's talk about function notation. And this you might want to write down, but you don't have to if I do it and you remember it all, right? So the parts of a function. The first thing is a function notation looks like this. F of x, I'm just writing a random function, 3x plus 5. And let's talk about the parts of it, right? This first thing, I want this. This first thing, that's just his name. That's just his name. You kids don't get it anymore, but back in the day, back in the 80s and 90s, we had vending machines all over schools, full of delicious candy and soda, because that's how different clubs made money. But you knew what, you would call it the teacher's lounge vending machine, and you called it the locker room vending machine, and you called it the front of school vending machine, because different vending machines have different stuff. They're all vending machines. They were just different names, right? So don't let this F fool you. Sometimes we call it an F, and sometimes we call it a G of X, right? That's just literally a new function with a new name. It's just calling it, instead of Steve, I call it F, right? That's his name. That's the first thing that we want to talk about. The next thing is this dude right here, the X. That, if you make a little machine, if you think of this like a little vending machine, this is the button that you're pushing. So imagine you've got one of those candy ones where you go E3 and you get M&Ms, or you get D2 and you get Twix, or you put J3 and you get Almond Joy, which sucks because Almond Joy is a dad candy and no one likes it, right? So, because it's bad, that's why. So, the buttons you push are called your input, right? And we also call this the independent variable. And here's why. Because there is no, I think it's dependent. There is no dad standing there with his gun into your head saying, you know, push F5, push F5. Like there's no one doing that. You push whatever buttons you want. It's independent. It's up to you. You don't want Almond Joy because who does? And you want Twix, you push those buttons. It's the independent variable. Variable. We also refer to it as often the X guy. It's the X guy, right? The stuff that comes out, the candy that comes out predictably is called, obviously, the output or the dependent variable. You know why? Because it's dependent on what freaking buttons you push, right? It's the dependent variable. And often we refer to that as one of two ways. Either we call it f of x, the answer, or because I'm lazy, we sometimes refer to it as y. I should this year put everything as f of x equals. Because everything we're going to do except for conic sections, which are round things, is functions. Like, guess what? If I'm typing 1, 2, 3, 4, that's 4 freaking typing things, and y is just 1, and I'm lazy. So, f of x, y, same thing. Same thing. Are we good? Everyone's cool? Okay. The way to know if something is a function, you can remember from Algebra 1 and Algebra 2 and Algebra 2 trig, the official definition, each domain corresponds to a unique range, or you can remember the Mrs. Tarantino way, which is it predictable? Predict, I keep spelling that different ways. Predict, okay, I can't. It's predictable. I'm adding letters. Okay, so we're going to look at some, and you're going to tell me, is it a function, yes or no? So, with your table mates, right now, I have 3 little functions up here, or 3 little sets of numbers. They're called relations. One of them is not a function. Talk amongst yourselves. Decide which one's not a function. Talk together. You can say, see if they agree. Remember, just because someone says it doesn't mean it's true. They could be really good looking, but not very smart. It's hard to be both. And don't forget, if you get something wrong, it's probably because you're the best looking person. So here we go. A is a function because look, 5 gives me 3, 2 gives me 7, 15 gives me 9. That's all good. Nothing. That's pretty predictable. This boring function, I push button 5, I get 3, 8, I get 3, 23, I get 3. It's not interesting, but yeah, it's a function. But this one, I push 5 and I get 3, I push 5 and I get 8, I push 5 and I get 23. Not a function, right? So rather than trying to memorize it, can you use X more than once? Can you use Y more than once? Instead, ask yourself, is it predictable? You'll get it right more often than you won't. Okay, next one. How about this? I got A, I got B. This is the same problem I just put in on a graph. Can you talk to your neighbors right now? One is a function, one is not. Can you decide as a table group which one is a function, which one is not? Talk now. Yeah, perfect. So B is not, and here's why. Because remember, this is what I'm plugging in. If I plug in 1, I get 3. Yay, that's good. If I plug in 2, I get -1. That's good. If I plug in 3, I get 4. That's good. If I plug in 4, I get 2. That's good. I made that number up. I got that wrong. But over here, here's a problem. If I plug in 1, I push button 1, maybe I'm going to get a Dr. Pepper. Maybe I'm going to get root beer. Root beer sucks. Like literally when that happens, like I'm really angry. It's like I just spent my money and now I don't have any money and I don't have a soda I like. Right? So that makes it not a function. You learned it in a different way. You learned it as a test called anyone remember? feel like Ferris Bueller's teacher. Vertical line test, right? If you hit it with a vertical line, but a lot of you are like, I do it, but I don't know why. And that's why. That's why if you draw a line and you hit it 2 places, it's telling you it's unpredictable. It's unpredictable. So with that in mind, one of these is a function, one of them is not. Talk to your neighbor, decide which is which. One of these is a function, one is not. A is not, right? Because it's not predictable. And I plug in this. Am I going to get this? Am I going to get this? I don't know. It's bad, right? But if you learn the thing called the vertical line test, is that why? What does that even mean? That's what it means. But here's my favorite ones. We're going to go a little bit harder here. And I'm going to extend this page up so we can get to this. Let's talk about this one right here. You got a cell phone as your range, your input, a cell phone, and a specific cell number. Is that a function? And I want you to think to yourselves, I want you to talk to each other. If you have a cell number, right, you've got a cell number, someone is giving you a number, and you dial that number, what should happen? Talk to each other. Is that a function, yes or no? Nice using math for that. If I call a number, will more than one cell phone ring? No, and definitely not here and in Yugoslavia, right? Like every cell phone is matched with a single number. That's how it works. It would be weird if I was calling my mom and a Yugoslavian man answered. Not bad, just weird, right? So cell phone numbers match to a specific cell phone. So with that in mind, how about this? I live at 4595. I just moved, so I'm very excited to write my address down. Deer Creek, if you live in Turtle Creek, you know where that is. I live there. That's my house. So my house to me. I want you to think about it. You go to my house. Do you get me? Talk to your group. Is it a function? Yes or no?
Yes.
What do you think? Is it a function? If you knock on that door, am I answering?
Yes.
No. Not all the time. Who else could answer, baby? My kids, my husband, absolutely. My wife, you don't know about me, right? Everyone's good here. But yeah, you don't know. You don't know who's answering that door. My boyfriend, reception. Yeah, I have a husband. And so yeah, you don't know. So this address can match to many people. If you wrote that address down and you said to the resident of, then there might be many people opening it. Last one, and this one you're going to think about for a minute. The domain, we're going to go a little bit opposite on this one. The domain is Oprah. The domain is Oprah. The range is a house. Is it a function? Talk to each other. Think about what you know about sweet Oprah. Yeah. She's giving up money. Like they were really not, because it's like, yeah, it's like she should have given, and she won't let him build a road. She's not an advocate. Yeah, if Oak calls you and says, "Hey, meet me at my house for lunch," yeah, do you go to Maui, or do you go to Santa Barbara, or do you go to Chicago, or do you go to Aspen? Oh, he's got stuff all over the place. So not a function, not a function. Okay, so back to a little bit more math. And this is where I may catch you a little bit. You're not going to love this part. It's been a hot minute since we've done it. We will keep practicing this. So the first thing is, back in Algebra 1, when you had very easy stuff and you wanted to write the domain and the range, you would write it as a list. Here's what I'm going to remind you. Please make sure you use D and you use R. So could you do me a favor on your whiteboard desk? Can you write the domain and range of this guy? And that is not a function, by the way. But that's okay. You still have the domain and range. So domain and range. I like using little brackets. Oh, I have a ton. Yeah. If your pen is bad, always let me know. I got.
Pretty sure.
Ooh, You're bad. If it's bad, throw it away. If it's bad, throw it away. But it's gotta be really bad.
Well, I don't know if it's how to do it.
Yeah. So make sure you throw it away. Don't take bad pens and put them back in the thing. Yeah, so do you see that? There's probably good. Make sure you get slow. Because it'll mean that. You can always try to see if you can get it in. No, you don't have to. Who else can you have? I got it. Go. Go to the recycle. Oh, come on. Oh, okay, you almost took the bag out, just letting you know. So we're gonna, when we do it, we're gonna, look at you, you're saying it's like, no, we're not doing that yet. Okay, so domain and range, do me a favor, -4, 2, -2, 5, 0, 3, 7, 9, and in this case, not a function. Could you do the same thing here? Yeah, here's when you use the list, when it's not continuous, meaning they are dots, right? When they're dots or points, you use that. We like that one. Other one, we love that. This is the one we don't love as much, right? It's been a hot minute since we've done these ones. Now I'm going to talk to you about this a little bit, and we're going to work on this for the next couple days a little bit. We're going to keep doing these. There are two ways to write when it's continuous. Most of the graphing we do in this class is continuous. So when I ask us, oh, and I'm changing this one, hold on. When I ask us to please write the domain and range, we're going to be doing stuff like this. The two ways to do it are called interval notation, which looks something like this, blank sometimes, or something like that action, right? Here's the deal. Mrs. Doc Weinstock was a set builder mama. Like this is what she liked. She wanted it very specific. She loved it. And the textbook that she was working with did it that way. Me and Mrs. Castello, I think Tobin as well, we like this because it's way, way easier. Because I have, so embarrassed to tell on myself, the little inequalities, I have to think about them. Like I have to think that whole alligator thing, like who's bigger? Like I have to think about it, and I'm lazy. I don't want to think about it. So here's why. If you came from Algebra 2 Trig and it was pounded into your head, this method, I had students last year in pre-calcs who stuck with this method. You do you. This is always right. And if it goes with you and you can get it right and you do it, stick with that. I will almost always do this because I'm lazy and I like it better and I think it's more efficient. But it's not wrong if you do this, but I won't be doing every answer in both, right? Because I'm lazy. You guys getting the hang of that, right? So if you are getting this wrong, though, if you were in Algebra 2 Trig and you're like, oh, I always mess that up, switch over to this one, right? Are we cool with that? Going good? So I am going to talk about doing this one, reminding you how to do it in set builder, right? I mean, in interval. If you remember set builder and you want to use it, knock yourself out. But I'm not going to reteach it because I don't use it, right? It's good. I can do it. I can do it now. I still like it. Okay, so here's what we do. When we do domain, we need to know two bits of information. We need to know the smallest on this side and the biggest on this side, right? Because we're trying to decide where the boundaries are of our little graph. Where are our boundaries? We love domain. And the reason we love domain is because we were taught to read in English. And in English, you read left to right. And domain goes small to big, left to right. So it's much easier, right? So what you're going to come over here and do is say to yourself, what's my smallest number? That's -2. What's my biggest barrier? 1, 2, 3, 4. Now, we're not quite done yet. We have to know, are those numbers included? Does it actually count, or is it damn close? If it's a closed dot, that means it's included. And I want you to think to yourself, that's hard, that's serious, that's this thing with corners, right? It's serious, it's included, it's a dark dot, yay, we touch it. If it's damn close, like an open dot or infinity, where you can't actually get there, when it's 3.9999999999999, then we say soft barrier, meaning right up to 4, as close as you can get, 1 atom away from 4, but not quite 4. Are we cool with that? Okay, range messes us up. I caught range on my kids' pre-calc final even this spring because I flipped them around and people hate it. Here's why range messes us up. It's, honest to God, the same thing, but it is down to up. And the problem is we don't read down to up. We read up to down, and that's wrong. It's little to big. So I want you to think about an elevator. So let's get our little barrier out. Our barrier is right here, and our barrier is right here. Sometimes those little things will help you. Having those little dots in there will help you. So let's start. What's the bottommost barrier? What's the lowest I can go? Someone said 1, 1. You are awesome. What's the topmost barrier? 3. You got it. And here's what. I'm actually touching 1, but I'm not actually touching 3. Does that make sense? Are we okay? It's been a hot minute. Yeah, it's been a hot minute. Okay. Let's try one that's a little bit harder, right? Let's do domain on this guy. Now, I want you to remember, he's going to keep on going forever and ever and ever this way. Forever and ever and ever and ever and ever. So the smallest I could go is negative infinity over here. And the biggest I could go is positive infinity. So one way to write this, yep, because he's going to go like this, forever and ever and ever. One way to write it is this way. Negative infinity, positive infinity. But you know what? We never actually touch infinity. We get close, but we never touch it. So boom, boom. Are we cool with that? But there's an even easier way to write it. If I can go every direction this way and every direction this way, there's a word when I can use every number in the world. What is that if I can use every number in the whole wide world? You remember? All real numbers, right on. And you know what? You just put this. A fancy R. That means everything's fair game. So anytime you go infinity to infinity, you don't have to do it. You can do the fun fancy R. And you know what? It's fun to write. You just do the R with the line through it. It's like St. Francisco. It's fun to say. Okay. Now, can you try with your table mates range? And I'm going to tell you, it touches right there. So I want you to see if you can do the range by yourself. Start at the bottom, infinity. Where do you go to the top? And you do it in interval notation or in set builder. Give it a try. Everyone should be writing something. You're trying the range on your own. Not because you can't actually get it. It's like you get near and you get shoot. Look at you not going back to one shot. No one does. Because you have to think about the things and you can get to live and you're still like, I love it. Hey, here's what I got. I know I'm gonna go again, this is the tough part. Our eyes want to start here and go down. They want to. I get that. I get it. But don't. Think about it as an elevator. I'm going to start down in hell, and I'm going to go all the way up to the first floor. I can't actually get to hell, thank God. but I can actually get to 1. Are we good? How do we feel about that? Are we okay? We got one last thing, and I'm shutting up, and this was the most I'll ever do, like literally for the whole year. I never talked this much, but I feel like we had to start. Can I take a little quick temperature of the room? Can, right now on a scale of 1 to 5, 5 being, this is the easiest class I've ever taken. Dear God, I wish I could drop because it's so, so easy. And 1 being, I have no freaking idea what you've been talking about for the last half hour. Can you give me a scale 1 to 5? Show me like where you're feeling. 5, easy. 1, super hard. You're going way too fast. I hate you. So you're showing me a 0. Hey, you're showing me a 5. Thank you. Appreciate it. Thank you. Thank you so much. Okay. Someone would have shown me a 1, and it would have been a rude one. It would have been bad. Okay. So the last thing we're going to do is algebra 1. Just a quick refresher that I've got a fun little function here, just a little baby one. Here he is, 3x plus 2. There are 2 ways to evaluate functions. There's going forward and there's going backwards. And some of you kind of forget the backwards. Going forward is nice and easy. It is when we say find f of 10. And what that means is we take 10 and we plug it in to x. So please, for me real quick, find f of 10 on your desk. Share it with your neighbor and see if they're as smart as you. If they're not, remember, don't pull back. They're probably the better looking of you. Bless you, bless you. I think I can say it together. F of 10. Let me move that up a little bit. So we're going to just say this. 3 times 10 plus 2, 32. Yay, life is good. But did you know you could go backwards? Meaning I'm going to give you the answer. Ooh, look at this. And you have to give me what number would work. How do you do that? So easy. It's a baby algebra problem. What you're going to do now is pop out this guy and put 17 right there. So watch what it's going to look like. 17 equals, look how easy that is, right? And then you move the 2 over and divide by 3. It's a baby algebra problem. So if the number is in the parentheses, you plug it in. If it's equal, you set it equal. Does that make sense? Super, super easy. If you got x equals 5, you are fire. Are you good? Okay. Oh my God, I'm tired, and I think, please let that be it. That is it. Yay, I'm turning this off. If you've been watching for 32 minutes, dear God in heaven, that is so